Hello viewers, this is Josephine. Welcome to the channel. Today we are going to look at equations of uniformly accelerated motion. When we look at these equations, we use them to solve problems of motion. And if you remember motion, there are some things that are important that you should note in motion. You should note what is uniform velocity, final velocity, acceleration, time and distance. And this is what they brought together to form these equations of motion. Okay? So let's see what these equations are. Equations of uniform motion, they are: number one is V equals U plus AT. Number two, V square equals U square plus 2AS. Number three, X equals UT plus half AT square. Then X equals U plus V over 2 bracket what? T. Where U equals initial velocity, V is final velocity, A is acceleration, T is time, and X is distance. There is one thing you must note about these equations. If a body starts from rest, that means the body was resting before it started making movements. At that point in time, its initial velocity is equals to what? 0, because the body started from rest. But if this body did not start from rest, it means that its first velocity becomes the initial velocity. Now also, if a body comes to rest while it's making movement and the body comes to rest, it means that its final velocity is equals to 0. Is that okay? Then acceleration is when the velocity of a body increases with time. But we have deceleration as when the velocity of a body decreases with time. So if we are asked to find deceleration, we are actually looking for acceleration. But deceleration is the same thing as retardation, or it will be a negative of acceleration. So we are actually looking for acceleration, but to have a negative sign. Though it's going to bear the same unit with acceleration. Is that okay? Let's look at a few examples of equations of uniformly accelerated motion. Stay tuned. Let's look at this example. A car takes off from rest and covers a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of its acceleration. Okay, like I said earlier, that once a car takes us from rest, that means the car was on its resting state before it started moving. Okay, so we assume that its initial velocity becomes 0. So we have that U is equals to 0 and covers a distance of what? 80 meters. So X is equals to 80 meters in 10 seconds. Time is equals to 10 seconds. We are looking for acceleration. That is what? A. Now, how do we solve for acceleration? If you remember the equations of uniformly accelerated motion, you are going to see the one that will fit in the parameters of what we have. So we are going to look at equation 3. This says that X is equals to UT plus half AT squared. I believe this particular equation have all the parameters we need. We have U, we have X, we have T, and we have A, which is what we are looking for. So this equation is fit for this question. So let's substitute in what we have to find the value of A. Alright, so we have that X is 80 meters. So this is 80. This is 80 is equals to U is equals to 0 time is 10 plus half times A times 10 square. Alright, so we have bring down 80. 0 times 10 is 0 plus half times A times 10 square is 100. We have 100. So we say 80 is equals to, this can divide it to give me what? 50. So I have 50 what? A. Since I'm looking for A, I'm going to divide both sides with coefficient of A, which is 50. So divide both sides by 50 by 50. Alright? 50 into itself once. I'm left with A. 0 cancels what? 0. So A is equals to 8 over 5. So with the help of the calculator, we have 8 divided by 5. The answer is 1.6 meters per second squared. Alright? So the answer to this problem is 1.6 meters per second squared. So let's see how we can use some other equations to solve problem. Stay tuned. Let's solve this problem together. A body accelerates uniformly from rest at 2 meters per second squared. Calculate its velocity after traveling 9 meters. So let us first state our parameters given. A body accelerates uniformly from rest. That means initial velocity u is equal to 0 and accelerate at this. Acceleration is 2 meters per second square. Calculate its velocity. Since we have its initial velocity at 0, so we are looking for final velocity. Okay? After traveling 9 meters, our distance is 9 meters. So the next thing we are going to do is to look again into the equations of uniformly accelerated motion and see what the one you are going to use that fit in the parameters given. So you should memorize or meditate on the equations of uniformly accelerated motion so that when a question is given to you, you will know the particular one to use to solve the problem. Is that okay? So let's look at this equation. V square is equals to u square plus 2ax, right? Since we are looking for v, so let's proceed. V square is equals to, my u is 0, that is 0 square, plus 2 times, my a is 2, times my x is what? 9. Okay? V square is equals to, 0 square is something as 0, plus 2 times 2 times 9. So let's work it out. I have 2 times 2 times 9. So I have 30 what? 6. Okay? So my equation is v square is equals to 36. Since I'm looking for final velocity, what I'm going to do is take the root of both sides by saying this and this. Sorry. Okay, so that this can cancel this to give me v. So root of 36 is going to give me 6 meters per second. It's going to give me 6 meters per second, right? So this is how we can use this second equation to solve problem. I hope you understand it. So let's look at more examples. If you are joining us for the first time, please subscribe to this channel for more educative videos because I'll be posting videos of this literally every day. Okay, so you can groom your knowledge in physics and also eliminate the phobia you have in understanding physics. So let's look at this last example. A boy moving with a velocity of 3 meters per second is brought to rest by a constant force traveling 15 meters. Calculate the retardation. Okay, looking at what we have, we see that this particular ball was already in motion. Okay, so with a velocity of 3 meters per second, that becomes my initial velocity because the body did not start from rest in this particular question. It was already in motion. All right, so my u is equals to 3 meters per second, right? Then it brought to rest. That means as the boy was moving with this speed, at the time he came to a stop, so he now stopped moving. That means our final velocity is equals to 0. So v is equals to 0. Okay? After traveling 15 meters, then the distance is equals to 15 meters. Alright? Calculate the retardation. Retardation is A. I told you earlier that retardation is a negative of acceleration. Even though we have to find retardation, it means that velocity decreases with time. Okay? So let's see the equation we are going to use to solve this. And we should also know that a retardation is acceleration, but it will have a negative sign. Okay, so we're going to use this equation again, equation 2, number 2. V square is equals to u square plus 2ax, alright? So my v is 0, 0 square is equals to, my u is 3, 3 square plus 2 times a times 15, because I'm looking for a. Alright, so 0 square is 0 is equals to 3 square is 9 plus 2 times 15 is 30. I will have 30 what? A. Then this 9 will cross over to this side to have a negative sign. So I have minus 9 is equals to 30 what? A. Since I'm looking for the deceleration, I'm going to divide both sides by the coefficient of A, which is 30. I divide both sides by 30. Okay, 30 cancel itself is 1, is left with A. So that means our A is equals to minus 9 over 30. Alright, with the help of our calculator, so we have 9 divided by 30. So my answer is minus 0.3. Therefore, my deceleration is minus 0.3 meters per second square. Okay, so this is how we can solve problem with motion. So knowing your parameters given, the first step is to state all your parameters given, and also to remember the equations of uniformly accelerated motion. Then see the one you can use to apply and solve your problem. Is that okay? Alright, so if you are watching this channel for the first time, give it a thumbs up and subscribe for more educative videos. I will put up an assignment. You have to solve it and drop your answer in the comment section. The more you solve, the more you know physics better. See you next time in my next class. Bye.